Hello everyone, in this video I'll be talking about time series analysis and I'll be taking two examples actually in total. In one I'll be smoothing the data, I'll be using moving average or something. But before that I'll be taking an example in which I'll not be smoothing the data. Data is pretty small, it doesn't show a lot of, I would say impacts which are to be studied. This is the example right there on your screen. And I'm going to use a multiplicative model of time series. If you want to understand time series in detail, what does time series mean? So there are four different types of trend and time series which you could see. And so what you can do is you can understand it through a very simple chart or something. So let me just show you what exactly the time series means. So if I have probably sales on y-axis and time on this axis, and this could be like sales of a particular automobile or something. And on time, this could be yearly data, this could be quarterly, and so on, and the things are going on. So probably this data is collected quarterly, quarter one, quarter two, quarter three, quarter four, and so on. And then again in next year the quarters start, and that's how exactly probably the sales of the entire firm are actually going, and something like this is happening. Now, one thing is you need to understand what is time series data. So whenever data is collected with respect to time, so one of the independent variable necessarily is time. Or you can see the chronological arrangement of data is called the time series data. So you've got this kind of arrangement of data. And so that's called the time series data. And there are different trends which actually exist in this data set. One is called the seasonal trend. So if you see in particular season, that means all 4 quarters the data is actually going up and down. So this is seasonal impact. This could be understood as a cyclic impact, that whether the entire business cycle is up and down. So there is a seasonal trend and there is a cyclic trend, and they vary or they occur actually all together. So the only difference between seasonal and cyclic is for more than 1 year, and seasonal trend is for within a year. So probably ready-made garments, if you see in winters, the clothes are sold more than in summers. They come down in rainy season again. The sales starts picking up, and in the winter again it goes more. So there are 4 seasons which impact the sales of ready-made garments, and same you can understand in automobiles or other businesses of this kind. And the cyclic trend even over or in longer duration, probably more than 1 year, the overall business is up and down, and these kind of cycles are coming up. You can understand in economics also these cycles. So these two different trends appear. There is one more trend which is called overall trend or the trend. So this is called a TT, a long-term trend, or it is also called a secular trend in the data. So YT, the sales actually is impacted by seasonal trend and the cyclic trend, which in our model of study, which will be combining together and we'll be studying them as seasonal trend only. Then comes a long-term trend, whether the overall business is growing or not. And then comes there are some irregularities. So probably there is this dot in COVID time sales where the sales were pretty down. So that's called irregularity of the data. So time series is actually about how the sales is getting impacted by all these different components which truly exist. So this is IT, and combining all together how we can make the prediction. So it is little advanced than regression. In regression, we do not consider all these components. So how I'm going to do this particular, so this is the question right here in front of you. You have got sales right here in this particular column. You have quarters, you have years. And so what I'm going to do is before diving deep into the analysis, I will insert one more variable of time here, and that would go like 1, 2, 3, 4, 5, and so on. So I'm going to just fill all these values up. So there are 8 time periods for which the data is considered here. So what is the game plan? This is the model which I have already discussed to you, how I'm going to make the prediction. So making the prediction is about extracting these components out. So this I will take as one, which is ST, and then I'm left with TT, long-term trend, and IT, irregularity. So fundamentally, it is about you can understand it like the tea. So tea, if you is you're served with the tea, it is a combination of water, milk, sugar, and tea leaves, or probably some other ingredients. So you have been served tea. So if you want to really understand the impact or of something, then what you need to do is first you need to decompose that tea. You need to extract the tea leaves out, you need to extract the sugar out, you need to extract the milk separately, you need to extract the water separately, and then probably you can make a better prediction. So now you can somebody can say what would be the taste of tea if you just mix tea leaves and water. So in that case, you will be just taking the milk out and sugar out, mixing tea leaves, hot water, and probably some of the tea. So it is something like the white tea, the sales has all the different components associated in it. So in order to make better prediction, I'll take the trend out, I'll take the seasonality and irregularity out, and then I will take the irregularity out. I will isolate the season by averaging it, and then I'll be making a prediction by using this model right here on the top. So what I will do is I will calculate the long-term trend by using regression, which you can see from previous lecture, and I'll be calculating once I calculate the long-term trend, I will take it on the left side of the equation, divide yt by tt, and you can see it's a simple arithmetic. I can get seasonality and irregularity. Then I will take average of each season, and then I will isolate ST. So now then I would have something like, because irregularity is ruled out. So in that case, I would be making a predicted of YP would be equal to my trend times the isolated seasonality. So that is what the game plan is. So I'm going to use regression first of all, calculate T, step one. Step two, calculate ST into IT by using this relation right here. Step three, I'll take the average of each of the season and use this to make the prediction. So you can remember these steps. Let's begin with it. So first thing is I need to know the trend. For that, I'll be running regression. So I'll take data analysis. I'll take regression. What is my Y value? So I'll take my Y component right here. Then the X range is the time period. Remember, do not take the quarters because it is going to repeat itself. Labels output range. Let me paste the output right here. Okay, and I click OK. Fine. Get the output. Perfect. Let me put the trend equation. How do I do the regression equation? You can refer to the previous video. So I'll use beta 0 intercept. I'll freeze it. Function f4 plus beta 1, which is right here. Function f4. I'll freeze it once again. And then I multiply it by the time right here, independent variable x, and I hit enter. Okay, that's my trend value. I just fill all the values right here. So I got my trend values. Now I need seasonality and irregularity. Again, get back to this particular thing right here. What I'm going to do for seasonality and irregularity, I will be dividing yt by trend. So yt is right here in this cell and trend is right here. So I'll be doing yt divided by trend, and I'll again fill all the values up. Now I'll take the average of season. That means I'll take the average of, so this is seasonality and into irregularity, right? And if you want to understand this, you can understand it this way. Look at this. The sales is 10 here and it is 0.92. So 0.92 is zero point 0.8 less than 100%. So seasonality and irregularity collectively brought the sales down by 8% somewhere. It is above 1.05. That tells you that seasonality and irregularity collectively pushes the sale up by 5% because it is one, it is one is 100%. So here you can understand that 15% sales in year one, quarter three, the 15% sales are pushed up by seasonality and irregularity together, and so on. So you can make these kind of attempts. Now I'm going to take the average of, I take the rule, the irregularity out. So I'll take the average of season. So quarter one, I will be taking average of this and this right here. For second, I'll be taking average of this value right here for the second quarter and for second quarter of year two. So either I can do it manually or I can use some advanced function of MS Excel. So I'll use an average f command. So I'll calculate average f range. So I'll say this range, take this range. I'll freeze it, function f4. Then last criteria. So my criteria is one cell to my left, which is in H16. So write it H16, pick it up from H16 right here. And average range is this right here, function f4. So look at this. What I'm doing is the formula is actually picking up in first cell, in if you see in quarter, I mentioned 1, 2, 3, 4. So it will be picking up from this particular column of quarters. It is going to pick up quarter one, because 1 is mentioned in net 16, and then it will fetch the average from seasonality and irregularity. If you want to understand how average if works, so you can refer to my previous video of advanced Excel functions. I can press Control Enter and look at this. All the cells are popped up. And okay, fine, looks good to me. Let us understand and use another Excel function to fill it up. So what I want to write here, I want to write average of quarter one, that means 0.84. Here I want to write average of quarter two, that means 0.98. Then here I want to write average of quarter three, that means 1.13. So either I manually type it, or I simply use my VLOOKUP function, look up value. So what I want to look up quarter one here, table array. In this table array, just look at quarter one. I'll freeze it, of course. And then I wanted to look into the second index. That means fed the average in this table. The average is given in second column. So column index would be 2. And of course, I want a false match. That means match it exactly. And I hit Control Enter, and that's it. So I've get average of season. So you can see that season 1 average is 0.84. You can check it here. Season 1 or quarter 1 average is 0.84. You can check here. 0.98 for 2, 0.98 for second quarter. So you can cross check. Let me make the prediction now. So I will be simply making, now I'll be making use of this. What I predicted would be long-term trend into seasonality. So it will be trend into seasonality right here. And I'm going to fill it down. You can also hit Control Enter. That's it. So I've got predicted value using the seasonality, which taken the irregularity out because it is of no use, and then using the trend values. Let me predict it for next 4 quarters here. So I'll be extending first of all this time value. That means I have taken it to 9, 10, 11, 12. On the basis of that, I'll be extending the trend values. Then I'll be just picking up these particular columns right here and extending them. However, I don't need this because irregularity has already been ruled out. Okay, these are the predicted values for next quarter, right? So these are the predicted values. You can see that. So that's a very simple application of multiplicative model of time series where the data was smaller. There was no need to smoothing out the data. There's no bumps in data as such. You can see that, and that's how the predicted values. So year 3, quarter 1 predicted sales would be 15.59. Years 3, quarter 2, the predicted sales would be 19.12, and